great. I'm super excited. Okay. All right. Last Friday, we talked about writing equations of lines. And again, we are writing equations of lines, and this is number 12 of where we left off. Again, the direction says write the equation of the line, and we have a nice little formula for writing an equation of a line. A nice little formula, super easy, which is times the quantity x minus x1. Beautiful. Y minus y1 equals m times the quantity x minus x1. And again, that's the formula we're going to use over and over and over again. It's a formula you need to know. It's a formula you should write down on a note card. It's a formula you should have memorized. So say it, write it, say it until you have it completely memorized. So we want to today be able to write equations of perpendicular kinds of lines. So last week we were writing equations that pass through points. We were writing equations that were parallel to. But today we want to write equations that are perpendicular to this equation. So, and that it passes through the point 3, negative 3. So we need, let's see, first we want it to go through the point 3, negative 3. But we need a perpendicular slope because this is point slope form, this equation of this line. So, Cash, what do you think?
Negative 4/3.
How did you come up with negative 4/3 for that perpendicular slope?
Like the opposite reciprocal.
Oh, opposite reciprocal. Yeah, we can see right here the slope of this line is 3/4. And so to be perpendicular, we would want the opposite reciprocal. Opposite changes the sign, reciprocal flips the fraction, okay? So now we have a point and a slope. It was really easy. I didn't need to write it all the way over here. And we can now plug in our information, the details, plug in the deets, okay? We want to plug in the point, x1 and y1, and our slope in those three places, and then we can write our equation. So we're going to write y minus y1. What is our y1?
Negative 3.
Negative 3 minus a negative 3 equals our lovely perpendicular slope, which is negative 4/3, times the quantity x minus 3. Great. Okay. So there was my point plugged in, and I can clean this up. Minus the negative is really
Plus.
a big giant positive. So I'm going to go ahead and just like overwrite that. Okay. So then I can distribute. What is negative 4/3 times x?
Negative 4/3 x.
Good. Negative 4/3 x. And then what is negative 4/3 times negative 3? Negative 4/3 times negative 3. Remember, that is 3/1. How do we multiply fractions?
Side to side.
Straight across. Yep. So yeah, we do end up getting 4. We're going to get positive 12/3, and 12/3 is 4. So we do get a positive 4. Again, this is perfect math land, where everything always turns out so nice, right? So don't skip this step. Don't try to do it yourself first. Don't jump right to the calculator, because it is easy and a good skill to remember. All right, then we can go ahead and subtract 3. So I'm going to subtract 3, and I get negative 4/3 x plus 1. And there is my equation of the line. Yeah, not too shabby, not too shabby at all. All right. So again, the directions here say, I'm going to jump down to 14. Write the equation of the line. Write the equation of the line. What is our formula for an equation of a line? Excellent. Y minus y1 equals m times the quantity x minus x1. Ladies and gentlemen, write it, say it, until you have it memorized. All right, again, we need it to be perpendicular. Very important word there. Reading, ladies and gentlemen. Reading is going to get you today, okay? So make sure you read carefully. So we need the equation of a line that passes through the point negative 5, 1, and I need a perpendicular slope. So again, I'm using notation to help me remember that I need my slope to be perpendicular. Well, perpendicular to what?
5/3.
Yeah, perpendicular to this equation, this line, 5x plus 3y equals negative 21. And so what do I need to do? You jumped to 5/3. Can you explain a little more about that?
So you would minus the 5x.
Okay, so you are writing it in slope-intercept form, solving for y. Okay, so I get 3y equals negative 5y minus 21, and then divide by 3. Sure, we need it in a form that we can recognize. Well, maybe you can get there more quickly sometimes, but I do caution, be accurate. Okay, so we know, what is the slope of the pink line?
-5.
-5/3. Okay, so that's the slope, and we don't want that slope.
3/5.
Positive 3/5. We want the opposite reciprocal. Change the sign, flip the fraction, and now we can write our equation of the line. So we're going to write y minus 1 equals 3/5 times the quantity
X minus -5.
minus the -5. Good. 3/5 times the quantity x minus the -5. And again, that minus the negative is really a positive there. We want to be a little careful. And then we can go ahead and distribute. So I have y minus 1 equals 3/5 times x.
3/5 x.
3/5 x. And 3/5 times 5.
3.
Yeah, plus 3. Again, 3/5 times 5, that's 5/1, becomes 15/5, straight across. 15 divided by 5 is 3, so we get right there. Real easy, and then we can add the 1, so we get y equals 3/5 x plus 4. And there is our beautiful equation of the line that is perpendicular to this one and passes through the required point. Okay, any questions of those? Pretty easy, right? Not too shabby. Okay, great. So now we go to perpendicular bisectors. Woo, baby. Perpendicular bisectors. What does bisect mean? Cut through the middle. Yeah, cut in exactly 2 sections. Bisect. 2 sections. 2 equal sections. So what we have here is we have line AB, or segment AB, rather, is formed by A, which is at -1, 1, 2, 3, 4. So there's point A. I'm going to write that down. I'm going to also put the -1, 4. Okay, gentle inch. And B is at 5, -2. 1, 2, 3, 4, 5, -2. So here is point B at 5, -2. If line L is the perpendicular bisector of segment AB. Oh, so I need to make my segment here. I need a straight edge. All right. So I'm going to make a little straight edge here so that I have a nice straight line. Whoop, there we go. All right, so there's my segment AB, and what I'm going to do is I have line L is going to be a perpendicular bisector of AB. What? Oh, wow. We want to write a linear equation for L in slope-intercept form. Graph both AB and L to confirm your answer. Graph will good. Okay. Well, so we need to find an equation, a linear equation for line L. So once again, I've got to use my point slope form, okay? I need to find an equation for a perpendicular bisector. What is that going to look like here? Let's see. Well, to bisect this segment, it has to go through the middle. The middle, as in the midpoint. Oh my goodness. Okay. So, oh my goodness, midpoint, ladies and gentlemen. Let's see. What is our formula for midpoint? You have two ordered pairs. How do you find the middle? If you had a test of 80 and 100, where's the middle?
90.
How'd you get 90?
You should place it that way.
Common sense, right? What is your average?
You know,
How do you find an average?
divide 100 by 80. Oh, never mind.
You what? You add and divide, ladies and gentlemen. You add and divide. Add your two scores, 100 plus 80. You get 180, and then split it in half into two. Okay. So, yeah, right? Okay, so the midpoint formula is x1 plus x2 over 2. Add your x's and divide by 2, and add your y coordinates and divide by 2. It's an average of the x's and an average of the y's, okay? Add and divide. So if I want to find the midpoint between A and B, I need to add my x's. So I have -1 plus 5 divided by 2, and I need to add my y coordinates. 4 plus a -2 over 2. All right, which gives me
I don't know. 3
-1 plus 5
4
over 2? 2, okay. 4 minus 2
2
over 2.
1.
Oh, hey, look at, there we go. Now, the nice thing about graphing, let's have a look here. 2, hey, look at that. There's my midpoint right there. And you can see if you were to graph it, like you were thinking, hey, look, to get from A to B, I went 1, and I can hit M. 1, 2, 3, 1, 2, 3. Down 3, right 3. 1, 2, 3, 1, 2, 3. Down 3, right 3. You see how you can sort of just stair step and get there? They should have the same, like you should be able to count it out too. Oh, of course, but you know, if your ordered pairs were like super far, right? Numbers bigger than 10, you know, outside the 10 to 10, -10 to 5. Okay, so you might not want to do that. But we can see it kind of here. So there is my bisector. And now, oh, ladies and gentlemen, how do I deal with getting my line to be perpendicular? Well, I did draw a line through M. Well, there we go. There's my drawing a line through it. Is that perpendicular?
I don't know, is touching close?
Oh, yeah, pretty close. Ow, this is
Something with reciprocals. We will need that. Reciprocal of what?
-3 over 3, which is 1.
Okay, so -3 over 3, is that the slope of line AB?
No.
Can we figure out what is the slope of segment AB? Can we figure out the slope of segment AB?
-6.
Lots of ways, right? Could I count my slope? I have a picture. I could count it. But what if I didn't have a picture? The slope formula, y2 minus y1 over x2 minus x1, right? So I could use the slope formula. I'm going to do that just because that's what, you know, you're not always going to have a picture. This is the point of math. The point of math is you don't want to draw a picture all the time and count. All right, the point of math is when numbers are large, we can still apply the process. So let's see, y2 minus y1. So -2 minus 4 over 5 minus a -1. So I get -6 over 6, which is a slope of -1, which, hey, confirms my 1, 2, 3 over 3, down 3 over 3, down 3 over 3, right? So now I just double checked myself. Hey, okay, so the slope of AB, so let's see. What I have here to write my linear equation then, to write my linear equation for line L, my point that I have is my midpoint, 2, 1, because I want it to go through my midpoint. And then I need my perpendicular slope. Well, what's my perpendicular slope going to be? Yeah, I'm going to take my slope here, I'm going to turn it into a fraction, change the sign, and flip the fraction, which just turns out to be a positive 1. Okay, now I can plug it in to my point slope form.
Wow, shut up.
All right.
I did not say, I said one thing.
All right.
Not the rest.
One thing's 4 times over. Yeah.
I said once and twice. What is this? This one is crazy.
Y minus 1 equals 1 times the quantity x minus 2. Using my point, my perpendicular slope. Y minus y1 equals m times the quantity x minus x1. Okay, I can distribute. I get y minus 1 equals 1x minus 2, and then I can add 1, so we get x minus 1. So let's see here. So there is my point M, and my slope is just going to be up 1 over 1. There it is, and you can see, so if I carry it out just a little bit, there's my line L. Does it look perpendicular?
You're pretty much.
Pretty much, yeah. It's pretty good. All right, we're going to do one more of these, but we're not going to do the picture thing. But that's the idea, that you should be able to double check, verify, if you will.
Are we forced to graph it on Delta Math?
No, no, you are not. All right. So we have segment XY. What do I need from segment XY? I need 2 things, actually. I do need the midpoint, and I also need the slope. So we're going to go ahead and find the slope of XY. The slope of XY is, oh my goodness, y2 minus y1, so 5 minus a negative 7 over x2 minus x1, so negative 3 minus the negative 9. What is the slope of xy going to be? 12 over
12 over
6. Negative 3. Negative 3 plus 9 is 6, which is 2. All right. We also need the midpoint. All right, we also need the midpoint of XY. How do we find the midpoint? Nope.
x1 plus x2 divided by 2.
Yeah, add your x's and divide by 2. So negative 9 plus a negative 3 over 2. Add your x's and divide by 2, and also add your y's. So negative 7 plus 5 over 2. Let's see, negative 9 and a negative 3 make negative 12 over 2, which is negative 6. And then negative 7 plus 5 is negative 2 over 2 is negative 1. So we get, I guess that's not very, negative 6, negative 1. There we go, now you can see it. Negative 6, negative 1 for the midpoint. All right, now to write our linear equation for line J, that is the perpendicular bisector. Perpendicular, what is our perpendicular slope going to be?
Positive 6, 1.
No.
Or wait, positive 1. Wait, no, positive 1, negative 1 over 2.
No, there we go. The slope, remember, here's our slope. My slope is 2 over 1, and we want the perpendicular, which would be?
Negative 1/2.
Negative 1/2. Opposite, change the sign. Reciprocal flips your fraction, okay? And we want it to pass through our point, -6, -1. So we have our point and our slope, and we're going to plug it into point-slope form. Perpendicular bisector, you need a perpendicular slope, and you need that bisected part, that midpoint, the middle, okay? All right, so we're going to have y minus y1 equals m times the quantity, x minus x1. I'm going to plug in my m there, minus the -6. So y minus the -1 equals -1/2 times the quantity x minus the -6.
Positive 1, positive.
Yeah, minus the negative turns to plus, minus the negative turns to plus, and then we can distribute. So we have y plus 1 equals 1/2, -1/2 times x is -1/2 x. And what is -1/2 times 6?
-6.5, or
Which is?
2.
3.
-3, yeah, half of 6. Half of 6 is 3. All right, -3, and then we can go ahead and subtract 1 from both sides, so we get y equals -1/2 x minus 4. -1/2 x minus 4. Ladies and gentlemen, do you have questions for me? All right, keep those notes handy, okay, because you need the slope and the midpoint of your segment. All right, ladies and gentlemen, you have a Delta Math, and I'm also going to open up your review. So when you finish your homework, you can start the review.